Before we get to our last big application of thermodynamics, which is electrochemistry, we're going to review a little bit of what we looked at with reactions. In the last video, I talked about batteries. Well, a battery is just a chemical reaction that releases free energy and allows electrons to flow. Electrochemistry is the study of that flow of electrons in a specific way that allows us to harness that free energy. It's all about electron transfer, so it's really about oxidation and reduction. So we do want to remember what oxidation and reduction are. Oxidation is the loss of electrons, which results in the increase in charge or increase in oxidation number. So losing electrons is to oxidize, Leo. Reduction is the gaining of electrons. We reduce our charge or our oxidation number, and gaining electrons reduces it. So we remember that with Leo the lion says grr. And we remember these rules for oxidation numbers. Sometimes it's really obvious to know what's gaining and losing electrons, but sometimes it's not as obvious. So we assign oxidation numbers to atoms within compounds to recognize what's going up and down from reactants to products. So we've got the rules here. These are the rules we go in, and we go in these in order. So I'm not going to read them to you, but for the most part, the idea is we know many of our metals based upon their columns, +1, +2, +3, but we have to figure out transition metals. The halogens tend to be -1, depending what their width, because oxygen is almost always -2. There are some exceptions to those things, and those are described here. And then we need to remember, if an element isn't bonded, it has no oxidation number. And if an ion isn't bonded, it tells us its charge. As we do redox into electrochemistry, we do have to think of these in terms of half reactions, meaning what is being oxidized, what is being reduced, and the real key to this is figuring out how many electrons are being exchanged. So right here, there's an example showing us an oxidation and a reduction, a loss of electrons and a gaining of electrons that can be put together. The nice thing with electrochem is we're very often given our half reactions. We just need to be able to put them together and put them together correctly to understand it in terms of oxidation and reduction. It is possible you might have to balance it with hydrogens or waters, although less likely because of the way the information is given. But always remember that we need to balance everything. We need to count the atoms, we need to balance our charges, and probably most important in terms of all of these things is keeping track of the electrons gained and the electrons lost. So we'll look at this example in a little bit more detail in terms of what it means for electrochemistry.